Okay, I will start our presentation by giving an overall McDonald's operations using the 4V's model. After my part, my teammates will continue with Six Sigma and volume stream mapping, so together we can look the business from three different operational angles. Let's begin with the first two V's, is the volume and variety. First is the volume. McDonald's serves huge numbers of customers every day. So the whole system has to work almost like a production line. The kitchen, the equipment, and the workflow are all designed to keep food moving quickly. Machines like automatic fryers and clamshell grills help the team repeat the same steps again and again without slowing down. So because of this, McDonald's can keep costs low and service speed very steady. And then we have variety. The menu is kept simple and modular on purpose. This makes the back of house run like an assembly system. Fewer switching tasks, fewer mistakes, and much more predictability. That's also why the experience feels almost the same across thousands of stores. So let's do high volume and low variety. Create the basic structure that keeps McDonald's fast and consistent. Now moving to the next V is variation, or now demand changes throughout the day. What's interesting is that McDonald's demand is very predictable. For example, lunch, dinner, and weekends follow almost the same part every day. This makes planning much easier, especially for staffing and inventory. To handle busy times, McDonald's uses flexible labor. Part-timers and cross-trained staff can jump in quickly when demand rises. And things like dual-lane drive-thrus and the mobile order priority lines help stores handle more orders without too much stress at the counter. All of this help McDonald's keep the unusual like 60 to 90 seconds service time even during rush hours. And then reliability really helps customer trust this brand, and me too. So the second part of this slide is visibility. Customers can see most of the service process, the queue, the staff, the speed, and even parts of the kitchen, because so much is visible. The operation basically becomes part of the consumer experience. McDonald's manages this by standardizing behavior and workflow. So the experience feels familiar no matter where you go. Open kitchens and visible food handling help build trust, especially around the safety. Like digital tools like digital menu boards also makes ordering easier, reduce waiting anxiety. When waiting for the McDonald's is maybe very anxious. So I think visibility doesn't just show what's happening, it actually shapes how consumers feel about the brand. And this slide gives a short summary of variation. Again, demand peaks follow a stable pattern, which makes planning much easier. Flexible labor and peak model feature helps the store deal with busy times. And proactive prep plus holding time rules keeps the balance between speed and food quality. Because of this, McDonald's can stay fast even when demand spikes. And finally, this slide is setting up visibility. Consumers see a lot of what happens in the store, so things like queue lanes, clean lines, and staff behavior become real-time signal of the brand. To keep this consistent, McDonald's uses standardized routines, transparent kitchens, and digital tools that help guide the flow. So, when the visible part of the operation looks good, consumers feel confident, stay in line, and often come back. So, overall, the four V's is value, variety, variation, and visibility. Help explain why McDonald's can stay fast, consistent, and scalable all around the world.
My name is Santosh, and our team decided to tackle one of the old, most recognizable and fascinating operation challenges, the McDonald's drive through. To analyze the legendary speed, we are applying a heavily hitter of operational toolkit, value stream mapping, or VSM. Think a VSM as an X-ray for a process. It allows us clear to see the flow of work, but more importantly, it exposes the waste anything doesn't add value for the customer. Because let's be honest, no customer pays to watch a burger patty sit under a lamp, okay? We focus specifically on the journey of the standard meal for the moment. The customer start ordering to the final handoff. The first crucial step was determining their demand rate, like taking time based on publicly available data for a high volume location. We calculate the McDonald's most deliver a finished order roughly every 54 seconds just to keep up. That's our target, okay? Let's go to the next slide. Now let's look the flow. This is our current state map, okay? You can see the five main process steps like the order taking, prep, and assembly. The good news, McDonald's has low cycle time. They are quick. They have perfected the speed of individual tasks. However, VSM forces us to look beyond the clock. Notice the three prominent inventory triangles between the steps. We are talking about pre-cooked patties, assembled burgers, waiting for the fries. This is necessary for speed, but it introduces a huge risk of waste through spoilage of poor quality. And here's the real kicker. Look at the assembly dressing station. Right in the middle, the percent complete drops just 90% here. Now, 90% sounds great, but when you're making thousands of orders a day, that means 1 in a 10 order has an error. That means a huge headache, extra work for the downstream team to prep again, like it's a big task. In the word of operations, means you basically guaranteed a rework in a 90, it's like a 90% in that. Okay, we go to next slide. This slide shows the hard truth of the process. When we aggregate the data onto this timeline, we see the total time of customer waits 20, it's like 220 seconds. If we divide by 60, like it's 3 minutes and 40 seconds, right? Yeah. The good news is value added time, the time the product is actually being worked on, is respectably 100 seconds. That's the green bar you can see under the totally time. Yeah. But now look at the red. We have 120 seconds of non value added time. That's pure waste. Mostly spent timing waiting in the drive through queue, waiting for the burger to be dressed, waiting to the fries drop with the coke. It's waste of time. It's actually longer than the work time. Yeah. By saying this, the contrast reveals that the process is only 45.5% efficient. We are losing more than a half of our total time to activities that customers doesn't care about. This is efficiency is far too low to reliable meet that 54-second taking time we established. Yeah. Let's come to a conclusion of the last slide. So to wrap up my findings are VSM has achieved its goal. It's to eliminate the primary source drag on the system. See the headline. It's simple. 45.5% efficiency is unsustainable. The core problem is the assembly dressing station. Its low quality of 90% is creating immediate effects and feeding the massive waiting waste downstream. In lean terms, it's like innovating new ideas. We have identified the biggest form of waste waiting and effects. The VSM current state map now gives us the evidence we need. We have proven the inefficiency, identify the root cause location. My colleague will now take this 45.5% finding, dive deep to analyze the root cause that are causing the 10% error. Then we propose the lean solution for a future state map. Yeah, which might help the McDonald's to provide more value to the customers. That would be great. Thank you.
Hello, my name is Lianli Yuan, and I choose drive-through service time consistency as the CTQ for this Six Sigma project because waiting time is a key service quality indicator in the quick service restaurant QSR industry. Studies show that long or inconsistent waiting times significantly reduce customer satisfaction and lower rapid purchase rates. For example, Philomena, Taylor, and Cruz 2021 found a strong correlation between perceived waiting time and customer satisfaction in fast food restaurants. Jian and Liu 2022 further demonstrated that waiting experience directly affect customer loyalty. Therefore, high variability in service time is identified as the main problem to address, and we apply the DMAIC framework for systematic improvement. We assume drive-through service time reflects overall operational efficiency, making it a valid and measurable CTQ. As internal operational data are unavailable, we use recent public benchmarks for baseline measurement. According to InTouch Insight 2023 to 2024 drive-through studies, QSR industry average service time about 3,043 seconds. McDonald's sample average about 3,075.7 seconds, indicating room for improvement. We define a reasonable assumption, upper spec limits USL, about 360 seconds, like 6 minutes. Orders exceeding 360 seconds are considered defects. This assumption aligns with industry standards and customer expectations, providing a basis for Six Sigma measurement, capability analysis, and subsequent improvement planning. Without internal data, we perform a root cause analysis based on public operations research and common QSR challenges, similar to a fishbone diagram. Demand variability, peak vs off-peak, high order density at peak times leads to queue buildup. Staff skill differences, varying levels of training, cause inconsistent execution. Product complexity differences. Different items take different preparation times, increasing variability. Equipment bottlenecks, shared fries, drink machines create queues. Order accuracy issues, mistakes require rework. Delaying overall service time. These factors collectively create process variation, which Six Sigma aims to reduce. Based on the root causes, we propose Six Sigma improvements. Standardize processes, implement clear SOPs. For example, prepare beverages first while food is being cooked in parallel to reduce execution variation. staff training to ensure consistent operations. Second is parallelized workflow, Lean plus Six Sigma prepare tasks that can be done simultaneously, reducing quick waiting times. Third is staffing optimization, focused based add trained staff during peak periods, retain essential staff in off-peak. Fourth is control phrase, randomly sample 10 orders per day to track total service time. Orders exceeding 360 seconds are investigated weekly. If 5% of orders exceed USL, adjust processes. These actions reduce process variation, stabilize drive-through service times, and improve customer satisfaction. Here are our references.